Students, as we have seen the dispersion of light through the glass prism, now let us see the practical example of that. Here, the rainbow that is formed naturally is the practical example of distributing white light got dispersed into 7 constituent colors. Okay, so how does it happen? Have you seen such kind of rainbow earlier? Here also, as you have observed that red color is at the top and violet is at the bottom. And why does so? Because the thing that I have taught you in case of prism is going to be followed everywhere. Yes, so that is the particular range of that spectrum, and according to that, violet is going to get bent the most and the least bended color is red. So here, how does this rainbow form? While raining, you know that there are lots of water molecules present into the atmosphere, and that water molecules are itself acting as a prism. One molecule is going to be acting as a prism itself, and when eventually at the time while it is raining and the sunlight, there is a small ray of sunlight coming out, and if it is going to meet with this water molecule, then it is acting like a prism for it, and there is the dispersion of the white light. And see here, how does it happen? It looks like this. If we zoom out the thing that is going to happen, you can see that sun ray is coming inside the water droplet and going to constituent itself, like disperse itself into its constituent 7 colors, that is red to violet. Okay, so that is because of the refraction. Here this act as a refraction surface. So after that, it is going to bend itself and making itself into 7 colors like that. Now this surface is again treating as a refracting surface, because now also this is a medium 2, medium 1, and now from here again it is going into medium 1. But at the time, what is happening, though it is going to refract, it can be go like this directly, but sometimes there is a incident angle, like these rays are going to fall on this refractive surface with making such an angle that it is not going to refract itself but reflect itself internally. Okay, that also happens. That means the light ray is not going to refract while it is going from one medium to another, but angle is such an angle that is known as critical angle. Okay, I must tell you the name of that angle. It is known as critical angle. If such an angle is made here at this point, then it is not going to refract, though it is going to again reflect itself inside the water droplet. That phenomena is known as total internal reflection. What we call it? Total internal reflection. Okay, that also could be asked in your exam. What is TIR? Total internal reflection. So you could say that when the light ray get refract from one medium to another, but again if there is a case of refraction and it is moving outward and changing its medium again, but this ray that is incidenting on the next surface is making such an angle that is known as critical angle, or more than that angle, more than this critical angle or critical angle, then it is not going to refract, though it will reflect inside. Internally it is going to reflect. And now here we are going to see the rainbow. That is why you are going to see rainbow on the top of the sky. Like on this sky is behaving like a screen right now. Like this may be possible, students, like if the rainbow is like coming, light ray is coming like this, and it is got refracted in this manner and got dispersed into 7 colors. So where does these 7 colors are going to make the image? This could be the surface. So the ground here, ground level is not going to be act like a screen. and you are not going to see if these rays are going to make image here. But when we are going to see, we saw this rainbow on the sky. So how does it happen? On the sky, that means sky is behaving like a screen for this rainbow. Then because of this phenomena, because of this total internal reflection only, this is going to be done. And now you can see all the colors that is forming by the white light. Okay, again the red one is here and the violet, so Vibgyor again is going to be followed, but the lines of the colors here are so thin that you are not going to predict each and every color. You are not going to distinguish each and every color separately, but you will see it like it is all the blending of all color together. But red most is going to appear because red is having a largest wavelength, and that is easily get followed and enter into eye, and that we can easily visible. That is why the thing that is of red color could be visible to us from the very far. Yes, but the thing that is blue color is going to disperse easily because the wavelength is so small. Then when it is going to interact with the even very small particle of the environment, then it is going to disperse itself like this. Scattering bolte hum isko. Okay. So this is what the dispersion of light, and this rainbow formation is the basic example that you can see naturally happened. So this diagram is very important, students. So practice for this diagram for your exams, and the method TIR could be asked to you. I have told you the definition part also. Now let's move forward.